as an Apache Oozie committee. Virag, and we will do the presentation of who will exchange model. So this presentation may be based on applications that recently been accepted at workshop in SIGMOD. And it is being accepted very well, and they asked us for an extended presentation also. So I will be going for presenting that in this weekend. So this will be my just rehearsal of that presentation. So it is a complete team effort. It's not a team within Yahoo. At least one person is coming from the cloud era. And yeah, so it's not my thesis there. I will not go for the roll call of all these questions, okay, just because that was me. So, as some of you already know, Oozie is a workflow system, and it is a bag of actions that you can execute. That's a very high level things. Today's agenda actually we presented in a different form, just using the Oozie's main theme of workflow system. That we will start with a quick tutorial that will demonstrate that how easy a user can install and utilize the Oozie. And we are doing this tutorial. Then we will go for some design decisions. Those will be little details things. We will go for some of the designs, decisions that we made and why we made those things. With respect to scalability and security. Then we will actually some of our benchmarking results that we started recently, like how Oozie can work, how good it is. After that, we will open up a QA session and we will more questions. We will go for we will address the questions, then come back to the questions, and then if the time permits, we will end. At the end of me stop. So, having said that, I will try to give it to Virag to continue the next session for 10 minutes. Yeah, good.
Thank you, Mom. Can you hear?
It's all right. Thank you, Mohammad. Hi everybody. So I will quickly show how we can easily use Oozie. The first step would be installing Oozie, and for that we need to download the Oozie platform. This link will be available on the Apache website too. The next step would be to unpack this platform. The third step would be to run the setup script. So for running the setup script, we need to point it to the place where Hadoop is installed. And also, if we want the Oozie web console to be enabled, we need to give the XJS library. It's just a JavaScript library. Then we can just simply start Oozie using Oozie start. And once we have started Oozie, we may want to check the status that it's running fine or not. Then we can do that. I will quickly go through steps 2 to 5. I'll skip step 1 because you don't want to download at the same time. Okay. Is it visible? This is the already downloaded firewall. I'll first unpack it. Okay. Once it's unpacked, we can run the setup script. So it's in the bin directory. I already have it in my cache. This is basically, I already have Mohammad installed on my local box, on my Mac. So, and we are also providing the JS library. And this will package, do all the packaging for the Oozie application, and now it's ready to start. So just run the start command. so we can check the status. Okay, so it's normal, that's good. Now we can go back. So many of you would be familiar how to run a standalone MapReduce job without Oozie. Basically just giving the jar file where the class is there, then we need to specify the mapper class, reducer class, and input directory, output directory. If you want to use Oozie, Oozie is basically, as Mohammad said, it's a workflow system, it's a tag of actions. So here we just have one MapReduce section. So we should have a corresponding workflow schema for that. And this workflow XML I will describe in the next slide. So basically the XML definition has a bunch of properties, as you can see. As this is a MapReduce job, we will have properties like mapper, mapper class, and reducer, input directory, and output directory. In addition to this, user can also define that own properties. So basically, it's not just limited to MapReduce properties. User-defined properties can also be added. For a workflow application, we require three components. First is the workflow XML, which I already shown in the last slide. Second is libraries. This is optional. So it's basically if you want to push any jar files or SO files along with your application, which the application requires, then you can have a lib directory. And what is the properties file? This file is used to parameterize the workflow XML. One of the mandatory properties here is workflow application, so it needs to point where the actual workflow is there on the application. And now just show how to submit it. For submitting, you need to run the workflow job. For that, we have run command. Once we run the run command, we have this workflow ID. Using this ID now, we can query the status of the job using the info command. I'll quickly show these two things on the command line. So we already have examples tar file bundled with the Oozie distro. So I'll untar it. As we want to run a MapReduce application, I'll go to MapReduce directory. And as you see, we have three components. And the workflow XML, they need to reside on the SPFS, so we need to push it there. So if they are already there, I have to first remove it. Either the Hadoop is already up, so you don't need to start it. And now I can copy the local files to SPFS. Also, we need to change the job properties to point it to the correct name node and job tracker. So I am running it on 9000 for the name node and 9001 for job tracker. And now I can run the run command using the job properties file. This gives me a workflow ID. I can use this workflow ID to query the status now. It's in running mode, and the same we also have a web console for this. This is a web console, it shows the status is running. If I click on the job, I can see different tabs like job definition. This is the definition you pass when you submit the job, the configuration that you provide. The job log through which you can easily debug your application, see whether you have a problem with your workflow or it's a problem with the Oozie server. And you can, if I click on this, I can also, this is my action node. And these are the Hadoop logs, the Oozie server submits it to Hadoop. You can also see the Hadoop logs from the web console. This is basically the Hadoop score. It shows that the match is already complete, so our application is already succeeded. So So this is how we install and submit workflow job and see the status. So like the control to Mohammad, you can go on with the further presentation.
Harder than the Oozie application. It's another way around as time. So we'll just now change the switch to an opposite. It was like how a normal user can use Oozie easily. We will now go change some architectural and design discussion that we have to bring up. Oozie is a cloud service, so we need to provide some basic feature like multi-tenant, security, and scalability. These are the very key features. We'll go each of them in the different subsequent steps. So first, just look into that actually when Oozie job is being submitted. I'd like to mention that Oozie can schedule peak job, high job, map renewal job, a lot of different types of jobs. So there are three different entities are here. One is the Hadoop cluster. Then there are Oozie server in the middle, and a lot of users are there. This is the representative users. So what guy he determined and explained his job that actually Virag already showed with workflow XML and other things. He defined all this there, and he submitted it to Oozie. Immediately, his request will face a security layer. That means that this guy will be authenticated to make sure this is a valid user. And after that, we will do some internal processing, and immediately it will go through submit the ultimate job to the Hadoop. Before submitting the job, it needs to make sure Hadoop is secure, so Hadoop with the security token, and that needs to be appropriately passed to Hadoop. So this is a normal process. As you can see, the security of Oozie is a two-end. When one end, individual to the Oozie, before it's coming to the Oozie. After it is giving back to the Hadoop user, that is also another level of security. So in next slide we will talk about the both end. First let's talk about the right side, Oozie to the Hadoop. So this is one of the critical things because now a Hadoop is coming with security, and there is a lot of issue to support in a multi-tenant service. It is a very challenge. I will tell why it is a challenge. First, look into some of the information out there. Those are first you will see unrelated, but we'll try to stitch them together. So first information, Oozie is a multi-tenant system as I told already, and Oozie need to schedule a job later. Right? Some user may submit a job now, he may schedule the job to schedule it next 1 year, every hour to run my jobs. So that means his job should run for a year without any help from the user. User will not come in every day and tell this is my new token to use it. So this is one of the important information. Third one, we find that Oozie need to automatically run this system. As I told you that for 1 year the job is running. And number 4 is, Hadoop will always ask, give me the security token before I accept any request. So all these things need to be there. The question is, who will handle all of these security tokens? That's the primary thing. Multiple users come. They are submitting the job to submit it later. And Oozie is the person, he doesn't know about the end user, how these security things will be handled. So this is the question that who and how to handle. And definitely you can expect that Oozie needs to handle this situation. Because Oozie is a gateway. He needs to know all of these things and handle this. How Oozie doing it? You can configure Hadoop. That actually Oozie request this feature to Hadoop. That to evaluate Oozie user as a super user. What does it mean? That Oozie can submit a job on behalf of the end user, where the security check will be happening to the Oozie level. The Oozie process, whether it is the correct Oozie process. Hadoop will never check the end user. whether individual is a correct entity. So Oozie will just make sure, okay, Oozie is the correct super is there, and I can rely on this guy, whoever is submitting the job on behalf of him, I will rely on him and do the process. So this is the checking is happening. This is the Hadoop and Oozie has an agreement, spatial agreement. So to do it, but the question is that while the actual job will run, if that actual job run and create some file, for example, who will own this file? End user or Oozie? There is the agreement also between Oozie and Hadoop that check myself for authentication, but run the job as the end user. So this functionality is being implemented in Oozie. And we are using the 2S functionality that will be the features of Hadoop that built for mainly for Oozie. So this is the one end. Come to the other end, Oozie end user to the service. First, you need to see actually why this extra Oozie security is needed. Already Hadoop security is there. Why we need to do at one level or another security is there? Because a lot of people might not need this Oozie security. Because there are 2 or 3 people are using their system. They know each other. They know one people will not kill another people's job. For these people, maybe Oozie security is working. Is an option. It's not a mandatory. But you know, most of the enterprise level application, while there is a multi-tenant system, true multi-tenant system, security is a must. So we design both. We are supporting the both. You will see. So why we need it, as I already mentioned, multiple users is supporting. One person should not modify the another person's job. We need to make sure. The another requirement I already mentioned that Hadoop check Oozie, not the end user. So who will test or verify this end user is the correct end user? It is the responsibility of the Oozie because Oozie has a super user, so it has a responsibility of checking who is working on behalf of that is a trusted user. So Oozie need to do this verification. So how Oozie is doing it? So Oozie is a built-in authentication system in the new version, and where the default support is for no security as I told, but we have a carbon authentication here. However, we're finding out that actually we support these things, but most of the customers, most of the companies, they have their own internal authentication system mechanism. They do not follow our thing. They cannot change their all authentication, all things being authenticated by one way, and now you guys are asking to follow your authentication way. So we are not enforcing that. We are our important design decision is here. We provide a pluggable concept. That means whatever module you have, you can plug into your own concept, and Oozie will work accordingly. So we are providing this flexibility. For example, at Yahoo, we support 3 authentication, and in addition of that coverage. So yeah, so that's actually one decision. From the security and other tokenization and other things, let's change our topics to scalability. Directly how we scalable things and what design decision may use a scalable system. So to do it, we have to consider Oozie that is processing a job, thousands of jobs at the same time from multiple users. So if we have this mindset, then you have to see how the problems are coming, how the design decision is being made. So when these thousands of jobs have been processed, the main problem is coming. Oozie have to submit the job to Hadoop. That's the ultimate thing. Or Oozie have to execute this high script, big script. So thousands they need to process it. How they can do it? Common solution people are thinking that why not create a trace for each of the job and wait for the job to finish, whether the job takes 1 hour or something. This could be one approach. This is easy. If you have a 5 or 10 or 20 jobs, you have to process 5. But when you have thousands or hundreds of jobs, is it a reality? So we see the reason actually, it is not possible. I will say the reason in the next slides. The reason is there is a 2 core. First is actually in one system, one service, running hundreds of thousands of threads simultaneously. This type of resource is not possible. It needs memory, it needs other resources. Also, you cannot support it. So we find out from a scalability perspective, it is not a startup for design. So that is one reason. The second reason is also more important in this case, that we are when we are telling that executing the job or executing the user job, what does it mean? We are running a high script or pig script or a MapReduce job or a Java code you want to execute. So all these things are user application. There is a joke I always tell that Oozie itself has a lot of power. We need to take care of those things. Now, if we run the user code on our system, it will create another layer of possibly thing. We have to handle the user error. They could throw a null pointer exception, they could de-stabilize our whole system, and that can impact the other user too. So from this thinking, we find out isolation is a very important feature, that we cannot run the user code on the Oozie process itself. Based on this, we took some decision that we will not execute anything on Oozie process. We will outsource this responsibility to an external Hadoop system. So we will launch a mapper job or launcher process there, and we will export all the user configurations there and run it from there. So that's the basic idea. From that way, the load is not in the Oozie level. That the stability or isolation is not questioned at all. So we are taking care of that. At the same time, we submit that launcher job immediately return. We do not wait for the job to finish. It might be waiting for one day the job is running. We do not care. Somebody has been to notify us that way, like your job finishes, now you do the rest of the process. So pictorially, the same thing, that's what I told them actually, that you just consider the Oozie server and their event cluster, and we immediately submit a launcher job, pass all the configuration that the user actually asked, and then as soon as the submission done, it returns. Launcher will independently execute the actual MapReduce job or high script or Oozie or Java, whatever it is. Then they got it done, and then asynchronously, number 5 is asynchronously, it is being notified to us, some notification process, that some job is being finished. Now you take care of your job. So this is the hierarchy. The question comes here, what is the benefits here? Why do we do this type of extra indirections of this? Why do we do it? There is a positive thing, there is a pros and cons both. The advantage one has been indirectly hinting them, there is a horizontal scale. That means, for example, you have now running 1,000 jobs. All on a sudden you loading this to 200 jobs. You don't need to change Oozie system at all. If your Hadoop system has 200 extra map slot to run, it should be fine. If you do not have, add extra machine there. So this is the main theme of the horizontal scalability. If you load increases, add extra resources. Stability thing I already discussed is lot. We are isolating all of this. However, disadvantages is also obvious. What we are doing, we are using extra memory, extra launcher mapper, extra map slot to run our job. We are consuming extra resources. We admitted that. We take this decision by discussing ourselves. We evaluated all the options and we choose it. With a thoughtful process, we choose it. It is a good idea. If we this disadvantage is an acceptable solution. Change the total here now. Now some numeric things. So there is a joke in there that this is I told you that this is a publication thing that we published to the SIGMOD workshop, and they are generally most of the academic people generally evaluate the paper. They have a professors and other things. They generally do not look to the industry things. They want to see the number, data, graph, show me that. Actually, those things come out from that, or we have been forced to add some graphs to convince them. Actually, we did a real beautiful work. So actually, this is the thing actually, but it is a good thing to have a benchmarking thing that actually show that where we are hitting the wall, how far we can do the scalability, where we will hit the wall. So those type of things actually is coming out from that. But I would also agree, this our benchmarking is a very rudimentary stage. We have to go a long way to find out everything. So you guys might find out some of the data is very challenging, very start. So anyway, so we provide some production things, your production things, how Oozie is being used, and what are our experiences. So as you know, at Yahoo we have more than 42,000 nodes in our clusters. We slice this in more than 25 clusters, more than 750,000 jobs per month. But we will present only from 2 clusters. We will see that. So first thing we will show that how the user is using. This is nothing where like Oozie is good or bad or something like that. This is the experience, like actually how in production people are using. You know, in theory you can tell a lot of things, but how production we are using it, that's only to show this. This is nothing telling Oozie is very good. So this is one of the things actually we can see here. We took 2 clusters and take the data. In the x-axis you see that there is a different type of jobs actually called the file system job, like file system data movement and other things. There is a Java code you can execute pure MapReduce code, and there is a P script is also there. When we took this data at that time, Hive was not being supported, but now in Hive is supported there. So as you can see on this data, Pig is very popular at Yahoo, and by compared to the pure MapReduce job. Pure MapReduce means actually direct MapReduce job. Pig is ultimately the MapReduce job, you guys know about that. But people always try to use another level of abstraction that is easy to use for this. And some Java code is also being very popular. They want to run their own custom Java code. Okay. So next one is our own manufactured or simulated environment. I told that this is the very beginning of our benchmarking. So we took a very small node system, 7 node system, where there are only 28 maps and some other specifications here. So I don't want to go through the details of that. Whoever is interested can do that. The next one is the job acceptance. This matrix is not important for everyone, but we find it out it could be important for some of the use cases. For example, Oozie is a process that people submit the job and go back home. They submit thousands of jobs, go back home, let Oozie schedule it and run it accordingly. So this is the plan. So it could happen that multiple users are doing it at the same time. So the load spike can go up at any moment. What is the load? The submitting and Oozie need to accept it, and then Oozie can process over the time. So for this type of request, that a lot of requests is coming to the Oozie, how Oozie handle those situations? This acceptance is only showing that. It does not show any other thing. We can process it fast. This is not showing that. The thing is we can accept that all the requests will process it offline. So for this thing, if we show it here on the x-axis, we actually simulate the user by creating multiple processes and multiple threads. In the x-axis, we show there is 640 threads we created that continuously submit the job, which is a very overhead actually. There are a lot of overhead in Oozie there. On the y-axis, we show that per minute, in every minute, how much workflow we can accept. So this thing is showing it here. As you can see that actually number of users, consider the x-axis is number of users. In Ethereum, you can accept more than 1200 workflow per minute. And we find it out this is sufficient for us. We didn't test more than that, beyond that scale. We can find out whether our graph still shows that it's going, maybe it will flatten very soon. We don't know that, we did not check it due to the time. So that's the thing. Now let's look at more. This is a couple of slides there. The timeline of the Oozie job. That's what happened. That you submit a job to Oozie, what happened to the Oozie? So first thing actually Oozie got, at this point we got the request. Then we submit to the Hadoop. Got the reply back from Hadoop. Then we reply to you that my job finished. And you can see that these two ends is the Oozie URL. So this is the thing actually, if you submit the job on a repeat job manually, this overhead will not be there. We need to estimate, if you use Oozie, how much overhead is there? User need to know that, how much time I am using as I am using Oozie. So this is the total Oozie overhead that we will estimate in the next slide. This is just this background. So we will see the addition of these two. So on this slide, actually, what we are showing in the x-axis, we actually do multiple experimentations. What we did, we submit a workflow with different number of nodes, that means different number of jobs. In the first one, we just only one job at a time. That's the example that Virag shows. That's a very rudimentary one. the rest of the one in the 5, that means in one workflow there is 5 actions in there, 10 actions, 50 actions, it depends. We have to see that how things are changing. And in one axis, you see the overhead in milliseconds, and how much Oozie level overhead we are getting. And you see that actually in only one action, the overhead is